Python Lab video submission, we are going to talk about the following items. We're going to talk about understanding the problem statement, the solution approach. One is the brute force method and the other is the optimized method. And then we're going to talk about the Python implementation of both these methods. The problem statement. In this, you have been given a list that contains both positive and negative integers. You need to find two elements such that their sum is closest to 0. The sum can either be positive or negative, but the absolute distance of the sum from 0 should be considered to find the sum closest to 0. For example, the test cases we'll talk about is if you have an input list of -4, 7, 6, 2 and -5, you should get the output as -5 and 6, as the sum of these two is 1, which is closest to 0, as we have nothing whose sum is equal to 0. Similarly, in test case 2, if you see the following input, your output should be -38 and 34. So when we talk about solution 1, which is the brute force method, so in this, for each element in the list, we'll find the sum with every other element in the list and compare their sums. So assuming that the sum of the first two elements is the minimum, we'll initialize a variable called minimum sum to the sum of the first two elements of the list. We'll then compare the sum of each pair of elements with the minimum sum. So we'll have two for loops. One will iterate from 0 to length of the list minus 1, that is the outer for loop, and the inner for loop iterates from the index of the outer for loop L to the length of the list. So if the absolute value of the sum of any combination of elements is less than the initialized sum, then we'll update the minimum sum with the new sum. The value of the variables L and R are also updated as we traverse through the list. We'll finally return the minimum sum as min underscore sum variable. The time complexity of this brute force approach is n square. Limitations is if there are more than one pair of elements for which absolute value of sum is same and closest to 0, then this code cannot capture that. It gives only one pair as an output. So we look at the Python implementation of this brute force method. So here we have defined a function pair of elements which takes an input list. List underscore size is the length of the input list. If the length of the input list is less than 2, we return as invalid because we need to have at least 2 elements. Now we defined variables such as min underscore L to be the index of the first element and min underscore R as the index of the second element, and min underscore sum as the values of the elements at index 0 and 1. Now as we iterate through the outer loop for L is equal to 0 to length of the list minus 1, and the inner loop we iterate from R which is equal to L plus 1 and the length of the list. Sum at any point is defined as the values at the index L and index R. So if any point, if the absolute sum of the values at index L and R, it is less than the absolute value of the minimum sum, we'll update the minimum sum to sum. We'll also update the index of minimum L and minimum R to L and R correspondingly. So we'll iterate through the loop, and as we iterate through the complete list, the values at index minimum underscore L and minimum underscore R will give you the elements whose sum is the closest to 0. If you look at the results, if you have a list which is 7, -8, -4, 7, 6, 2 and -5, the brute force method algorithm will return 7 and -8 as the output elements whose sum is closest to 0. The second approach is an optimized code. It will perform better and is more efficient than the brute force method. In this, first we are going to sort all the elements of the input array. So once all the elements of the input array are sorted, We will use two index variables, L and R, to traverse the list from the left and the right hand side. So we'll initialize the left index to 0 and the right index to n minus 1, where n is defined as the length of the input list. So at any point, sum is defined as the sum of values at index L and R. So as we traverse through the list from the left and the right hand side, if the sum of the values at index L and R is negative, then we increment the left index to L plus 1. If the sum is positive, then we decrement the right index to R minus 1. If the absolute sum of values at L and R is less than the absolute value of minimum sum, then we update the minimum sum to the new sum. We continue to repeat the steps 3, 4, 5 and 6 till the left index is less than the right index. The time complexity is the complexity to sort the algorithm, to sort the list, plus to complexity of finding the optimum pair. It's n log n plus n, which comes out to be n log n. So n log n is the time complexity of the optimized code. Limitations is if there are more than one pair of elements for which the absolute value of sum is same and closest to 0, then this code cannot capture that. It gives only one pair as an output. So if you look at the Python implementation of the optimized code, the solution 2, we've defined a function pair which is an input list. We've defined two variables, sum which is initialized to 0 and minimum underscore sum which is initialized to a very high value, for example 10 to the power of 9. N is defined as the length of the input list. L is defined as the index of the left side as we traverse. R is the index as we traverse from the right hand side. So L is initialized to 0 and R is initialized to n minus 1. We've also defined variables min underscore L and min underscore R to keep a track of the index for the left and the right pair for the minimum sum. So minimum underscore L is defined as L and minimum underscore R is defined as n minus 1. So similarly, you should have at least two elements in your list, otherwise it will return an error. So first we are going to use the Python's inbuilt sort method to sort the input list. So input underscore list.sort is going to sort all the elements of the list. So while the left index is less than the right index, we are going to update the sum variable to input underscore list of L and input underscore list of R. So basically sum is the sum of the values at index L and R. So if the absolute value of this sum is less than the absolute value of the minimum sum, then we are going to update the minimum sum to sum as well as update the index values of minimum underscore L and minimum underscore R, which is the index values at which the sum is the minimum. If the sum is less than 0, then we are going to increment the L to L plus 1. So we are going to increment the left index to L plus 1. If the sum is greater than 0, then we are going to decrement the right index to R minus 1. So we will continue this till your left index is less than the right index. Finally, we return the values of the list at index minimum underscore L and minimum underscore R. So these two values represents the values whose sum is closest to 0. So if you look at the results of the solution 2, if the list is minus 4, 7, 6, 2, minus 5, if you call the pair method of the solution to optimized code, it will return minus 5 and 6. So the sum of which is 1, which is closest to 0. So we found that the solution 2 is more optimized and efficient, and the time complexity of which is n log n, uh, and the results are as shown. So, thank you very much for listening.